Hi, everybody. This picture that came from a Medium article that popped up in my feed, conveniently, thanks AI, captures what we're trying to do today. Before we had a server that could only interact with a single client. What we want to do now is use threading to allow our server to create a separate thread for interacting with each client that tries to connect to it. So from last time, here was our server class. At the very top, we have our server socket, and the server socket waits for a client to try and connect. And when it does, it accepts that client and creates a socket object for that client. And then everything that happens after this is related to that particular client. So everything that I have selected here is what we want to have happen in its own thread for each client that tries to connect. So like we did last time, let's create a class that implements the runnable interface. So I'm going to create here a new Java class, which I will call client handler, because it is for the server to handle each client. And we want to say implements runnable. Let's make the fonts a little larger here. And it's saying that we haven't actually implemented the missing method. So let's implement the run method. Here we go. As we usually do, let's get the fields first. So jumping back to the server, it looks like we'll need fields for, well, we'll need fields for the actual socket itself, and then the print writer and buffered reader. So let's do that. Private socket client, and then buffered reader, which we'd call in, and print writer, which we call out. And we got to import socket. And then we'll want a constructor, client handler. And let's take the socket as an input, because we still need the server to actually accept the request to make the connection. And that returns a client socket here. So after the socket gets returned, I think that's the time when we want to create our handler, and we'll hand it the socket that just got created so that now this separate thread can be handling that. All right, so let's say client equals client socket, and we'll say in equals new buffered reader, new input stream reader from client dot get input stream, and out equals new. Oh, by the way, since it might be a good idea for you to try and like reproduce yourself the same code before you watch me do it, just to practice, because it's the same pattern of object creation every time. And since we're doing it, it's nice to try and get it in your memory. You know, your memory like with help from the IDE, which provides some significant help. Why does it not like this? Oh yeah, right. So like we did before, let's not actually wrap these in try-catch blocks. Let's add exception to the method signature. So it might throw an IO exception if these things fail. So back in the server, let's now grab this code, which is actually responsible for handling the client requests, and we'll put that inside run. And we'll throw our exceptions if they happen. Oops, what did I just do? No. Oh, we're already inside a try. Hold on. All right, so I guess let's handle this. So since we're already in a try, let's say that we'll catch, was it an IO exception? Probably. And now, harumph. Okay, so if you've forgotten this, we talked about this before, but when a particular type of runtime exception happens inside the try block, instead of just crashing, which is what happens when you throw the exception and it doesn't get handled, we will handle it, which means that we're going to try and catch the particular type of error that's happening. This looks like a variable declaration. As you recognize, we've got a data type and a variable name. So when the runtime exception occurs, all the information about that exception gets bundled up into an object whose data type is IO exception, and E is the variable that holds that object that contains all the information about the error. So instead of crashing, it will run the catch block, and it'll give us a chance to display things. So let's do this. System.error.println, and we'll print IO exception in client handler. And if we want to, we could also e dot get stack trace. All right, fine. And then really cool. All right, good enough. All right, so wait, have we done the things that we want to do? So we are accepting the client socket as input. We're creating our input and output streams. We are doing the same thing that the server used to do, but now inside the run method for the runnable interface. And then, I must have auto-fixed this somehow. So this used to say get random name, right? So I guess it's up to us if we, was it static? Yeah, so it was a static method inside the server. So if we want to, yeah, I don't see any reason not to just request the server to do this work for us. If we wanted to, we could move all of that code here into the handler, but that seems fine for the moment. So back in the server, it seems like we'll need some way to store all of the various threads that are getting created. So let's make an array list of client handler objects called clients, which I will create here. Or I guess there's no reason not to, no reason not to instantiate it up here. Okay. And we want this, well, all right, so we're not doing this stuff anymore. But we want this part that listens to accept connections to be in a loop. So let's put that in a loop. And it can be an infinite loop, that's okay. Okay, so once we've accepted the connection, what we'll do is we'll make a new client handler object. We don't have something called client yet. Oh, we do. Client thread equals new client handler, and we'll give it the client socket as an input. And then let's add it to our list of clients. Cool. Wait, what? Everything cool? No. Wait, what did I just do? I should click on things less quickly. Oh, because this isn't static. Okay. And then we actually want to run it. And if you remember from the threading video that you saw just a second ago, I think a good way to do that is to have an executor service. Yes. Which I'll call pool. Okay, so executors, new fixed thread pool. I don't know, so 4 is like a very small number of threads, but let's make it 4 right now for testing purposes because we're not going to have that many clients connected. So then we can ask the executor to run. So pool.execute. What did I just call it? Client thread. Okay. Oh, and I'm really bad at remembering to make these static. All right. Okay, so let's try it. Here's the server. Run the server. Here's the client. We'll run the client. Hello. That's not what we're expecting. You know, this seems suspiciously like the same problem that we've had in every single video so far, this auto flush. Let's see, okay, so the client is sending the output to the server, but then the client handler is what sends the output back here. Yep, that was the problem. Okay, cool. Remember, a good thing I'm working from notes, right? Okay, let's try it all again. So server, cool, go. Client, okay, go. Client says hi. All right, server says that. All right, so we still have one client. Let's run a second client now. And you can see I've got two different client windows. So the first client can still request a name, and the second client can say hi. The first client is still there. Cool, so it seems like this is working. I wonder what happens if we try and connect more clients than the number of threads in the pool. Let's try it. 3, so name, and then fourth client, name, and now this is the one that should fail. So I think, yes, so it appears that the client believes that it's connected, but on the server side, it's still waiting for a thread to open up for the thread pool, from the thread pool. So that would be an interesting bug to try and fix, because obviously we would want to let this client know that they're waiting in vain. Anyway, we can come back to that later. So as the last part of this, let's open it up so that it's more like a chat client, so that each client could broadcast things to all of the other clients. So I haven't planned this, so I'm thinking out how's this going to work. Here, I'm going to pause it. Okay, so let's pass in, well, I didn't really actually plan it, but let's pass in a reference to this array list. Because what I'm thinking is, let's have each client handler have access to all of the clients so that we can loop over them and tell all the clients something. So here we'll say clients. And now in the client handler, we will accept an array list of client thread, right? I think that's what it is. No, client handler, which we'll also call clients. Great. And then we'll save that up here. I'll say this dot clients equals clients. All right, so let's keep it this way. So if they request a name, great. Let's add another else if statement. So else if request dot starts with, So if it starts with the word say, let's pretend that that's the client trying to say that they want to say something out loud to everything else. So let's do this. So out to all, and then I'll say request dot substring. Or let's do this. Let's find first space is going to be request dot index of the first space. And so then, oh, not single quotes, double quotes. And so now I'll say if first space exists, then let's display to everybody a substring starting at the index of the first space to the end. So in other words, they're saying say something, and then whatever comes after that is what they're going to say. What's the problem here? Oh, starts with substring. Thank you. Okay, so now let's make out to all, where we're going to loop over all of the client handlers. So I'm going to use the for each style loop. Oh, other way around. So a client, and then I call them clients. And so now I'll say print line string. Except let's rename it from, or let's name this message. All right, cool. I think this is going to work. Let's try it. So we will run the server. Whoop, come on. We will run the client. Let's just run 2 clients. All right, so let's make sure they work separately. So this one can get a name. This one can get a name. This one will say hi. And it immediately gets back, server says hi. Here it doesn't seem to have worked. But if you remember the way that we wrote the client, right now, this client is still sitting here waiting for someone to type something at the keyboard. So let's say name. And now it gets the message that the server sent. Because we didn't design the client side to be able to just receive information from the server without getting blocked by reading the keyboard. So to fix that problem, now we have to implement a handler for the client also that runs in its own thread. Okay, so let's make a new Java class, which we'll call server connection. And we'll say it implements runnable, just like we did last time. Let's implement the missing method, run, okay, let's make a constructor. Oops. Constructor. What do we need? So like last time, let's make a socket. Sure, we'll call it server, that seems okay. And like last time also, let's get a buffered reader and a buffered writer. Okay, and then here we need a socket as an input, and we'll say server equals s, and then let's copy and paste the same creation code here, except we called it server. What's the problem there? Oh, right. Okay, we're remembering all the things. So we're adding the exception to the output. Okay. So what do we want it to do inside run? Since this is only responsible for handling inputs from the server, oh, actually, I guess in that case, I don't really need an out. Well, since this is only responsible for handling connections to the server, handling input from the server, really I just want a loop that waits for the server to say something and then displays it to the user. So let's do that. So in client, really, like this is what I want to be doing here. Except I didn't call it input, I called it in. So I'm reading in from the server, and I'm printing whatever the server says. And I think that's all we want this to do. So let's do that. Sure, fine. And let's also have, you move in here. And then finally, what am I closing? In.close. Okay. And then I guess let's delete this. Okay, here we are back in the client. So what do we want to do? We've got the socket, we've made these things. I guess we don't really need the input one anymore because that's going to be replaced by our new object. So let's make our new object. Server connection, or let's call it server out. Well, we'll call it servercon. New server connection, and we're going to give it our socket as input. And then I guess we can just declare it here. Cool. All right, so we still need the keyboard. We still need the write out. That makes sense. So now we're in a loop. Oh, but now we need to, before we enter our infinite loop that's about sending things to the server, we have to start the servercon here. So this is a case where we don't actually want to pool of threads because there's only a single thread that's ever going to happen in the client. We're not handling like connections to multiple servers. So this is a case where we can really say new thread server connection dot start. So we created a new thread and we're starting it. And now we're entering this loop where we wait for the user to type something, and then we'll quit if we need to, and send it to the server here, but then we don't wait for the server reply there. That's handled separately. Okay, cool. Let's test it. So we'll run the server, and let's run a client. Cool, there's client 1. Let's just make sure we can do something. Ooh, cool. Hi everybody. I stopped the video and I debugged my problems, and it took me a surprisingly long time to find the problem, which in retrospect is really obvious, which is often the case with bugs. Here I am inside the server connection that we just finished writing. I have the while loop here, so I'm saying let's continue this infinite loop in which we'll try this code. Remember how I said finally is the block that runs once the try block is finished? So what's happening is I try and read a line, I display whatever the server says, and then I close the connection. But once the connection is closed, I go back up here and I try and read another line for the server. Once the input stream is closed, it actually closes the entire socket because the server thinks that you're trying to disconnect. So that's what was causing the problem. So the solution is to say what I actually want to say, which is I want to try those two lines of code in an infinite loop. And let's fix the bracing. And we could say, like, if the server response is null, then that means that the server has booted us off. And so we can break out of our infinite loop. This is the relevant chunk of code, and this is all just handling exceptions and cleaning up. So just reverse the order of the try and the while, and hopefully that problem will be solved. In fact, let's verify right now that it is. So I'm going to run the server. Cool. Let's run the client. Cool. So here's the client. I'm going to type name, and I see Felix the Gentle. Let's make another client. Here's another client, name Wiley the Gentle. I can still see Felix the Gentle. And now if I say, hello everyone, I get bounced back from the server, hello everyone, and this other client also got the hello everyone. Well, at this point, it occurs to me that maybe it would have been good to give the clients names so that we know who is saying what. But this video is too long already, so we're going to stop it here.